Hey, and welcome to the Protopod, the podcast where we talk to innovators, engineers, and visionaries who are shaping the future of technology and manufacturing. Joining us today is David Hagan, the founder and CEO of QuantAQ. QuantAQ designs and manufactures internet-connected air quality monitors that measure pollution more affordably than traditional lab instruments. QuantAQ's products are used by everyone from NASA and the EPA to leading companies in mining, construction, and transportation. David started QuantAQ 7 years ago, straight out of his PhD work at MIT, where he focused on practical, scalable air quality solutions. Today's episode, we'll talk about David's research, his startup philosophy, and how QuantAQ has successfully evolved from prototyping to production. Let's get into the show. David, welcome into the Protopod. I have the pleasure of interviewing you today. I know you have a very interesting background, an expert in air quality and air quality monitoring. You're the founder and CEO of QuantAQ. Before we get into what you're doing now, can you give me the history of how you came to founding your company?
Sure. So I founded the company directly out of my PhD work at MIT, and it was actually a pseudo requirement of the fellowship that I had through the Tata Center for Technology and Design, through the MIT Energy Initiative, that my research and everyone who was in the program's research be much more applied. And so the objective was to steer master's and PhD level research to end with either a company or an innovation that could be put to use right away rather than in 20 years.
Amazing. I think that's really interesting. I've actually never heard of that being done. What do you think the advantages are of kind of directing young, really bright students who are innovative into a creating a company or a business out of their research?
Yeah, I think it. I think it's great. However, I think it really depends on obviously the type of person and also academic advisor that are involved. You know, being even at a place like MIT, which is incredibly entrepreneurial and supportive of spinning out companies, as is kind of seen by the track record of MIT and people from MIT. There's still, especially in the environmental and especially environmental sciences, there probably are fewer people that are interested and are ready to take that leap and commercialize something, as opposed to going into academia or working for the government or something like that. But I think that overall, it's been incredibly productive if you look at the track record of even just the program that I was in. There are at least 10 companies that I can think of that have spun out of that program. And it's not a huge program in the last 10 years, many of whom are actually or have been located in the co-working space that we work out of. So I think it's been a very productive way to start companies specifically that help people that otherwise are overlooked.
I think that's very well said. The bringing it to market and making it a function of what the offerings are out there and making a real impact, rather than kind of being tucked away in academia for a delayed period of time. I think you said 20 years. So what is it that QuantAQ does differently than the other air monitoring systems that are out there in the market?
Yeah, so we produce high quality instruments that work reliably and generate accurate, actionable air quality information for a fraction of the cost, both in terms of capital costs, but also operational costs. So your traditional air quality monitoring station operated by the EPA or state agencies or local agencies typically consists of anywhere from $100,000 to $500,000 in capital equipment, plus is housed within a shipping container or a portable, house or something that has HVAC and all that, because the instruments need to be kept cool and all these sorts of things. And on top of that, you need, at least a fraction of a person to be there to look over the instruments, calibrate them, to make sure they're operating properly, download data, all this sorts of stuff. And we can do, ours are not quite as accurate as those instruments, and they're not designed to be, but they're very, very close and cost, on the order of $5,000 and are, less than a cubic foot and are connected to the internet and take advantage of modern computing and infrastructure and, the IoT networks that have gone up over the past decade to make it as quick and easy as humanly possible to get up and running to collect data that you need to understand what's going on.
Yeah, so very much by a factor of 100 in terms of capital cost, a much lower barrier to entry, and a solution that is likely good enough, just barely any amount less accurate than the much more expensive option. So when I think about that, that's a massive scale in price difference, and I can imagine that that technological innovation presented many challenges. Do you want to walk me through what core principles you might have used in making that big leap to that technology?
So I come from even at the undergrad level doing research. I did research in a very similar area, mostly developing very, very expensive analytical instruments to measure and answer specific research questions. So mass spectrometers, gas chromatographs, really, really nice instruments. And while they're expensive and complex and can be hard to use, there are a lot of tips and tricks that we take with us to this lower cost area that help us get vastly better data. And so I think, we have competitors out there who do somewhat similar stuff, or at least trying to do somewhat similar stuff. And the thing that sets us apart is that we are coming, we're scientists. We come from the land of developing $1 million mass spectrometers to do this sort of stuff. And now we're trying to do something very similar for $1,000 or $10,000. And at the same time, our expectation for data quality and reliability is, higher than it was before. So it's kind of an impossible task, but it does help us drive everything in sort of the right direction, and doing everything kind of from first principles and making sure at every step of the way that, data quality and reliability and accuracy are paramount. And so, often I describe there are two opposite ways to get to sort of a mid-cost device. You can either start with the really expensive stuff and keep data as your sort of North Star and try to drive cost down as much as possible, whether it's through manufacturing of volume or, doing things like, learning how and doing bent sheet metal work instead of molding or, CNCing stuff. Or from the opposite direction, you can start with a cheap sensor and then try to make the data as accurate as possible through, often through algorithms and tricks like that. And so we take it from the first. We have to have good data. We try to drive the cost down as much as possible. And I think that has really allowed us to still produce very reliable, accurate instruments, even though the sort of the end cost is about the same as some of the other guys out there.
Yeah, I think it's a great description, and obviously that methodology that approaching from data quality first and quality of sensors, and then trying to reduce the costs that wrap around that as much as possible. I think that would obviously present challenges, and I know a topic we talk about many times on the show is this idea of moving projects or innovation at speed. We term that internally as high velocity mass customization. Long story short, it allows people like yourself, innovators or project teams, to stay focused on the task at hand and get rid of any latency that may kill project momentum and ultimately lead to poor outcomes. Can you maybe expand on how that concept and that idea of moving quickly as you've attacked these difficult designs has maybe helped you?
Sure. As any startup, but especially in the hardware space, that is our biggest advantage, and one that you cannot afford to throw away, is just the ability to iterate as fast as you. We can turn around a new revision of something in days, as opposed to years that it might take if you're working at a large company. And there are a number of ways in which we're able to do that, including by having different vendors for rapid prototypes versus scaled production. Some of them are the same, some of them aren't. It kind of just depends. And, we try to build those relationships with different vendors and understand what people are good at and are capable of doing. The manufacturing space has just changed dramatically over the last 10, 15 years. And there are a number of companies where you can just go online and order CNC'd stuff or 3D printed stuff or whatever it is, circuit boards even, assembled in 3 days, which is crazy relative to sort of where things were 15 years ago. And similarly, having the in-house capabilities of doing a lot of it. And so, being able to lay down basic circuit boards ourselves or to 3D print. Obviously, 3D printing has transformed the ability to manufacture rapidly, even if it's just for fit testing or something like that, and you're not actually going to 3D print, a final part. Having those tools available and knowing how to use them has made it possible to iterate in hours or days instead of months or years.
I think that it is. It's a game changer, and it allows you to ultimately reduce your time resource, as well as your overall investment into the project. So very well said. I'm wondering, I know you had mentioned in there kind of scaling up from prototyping to full scale manufacturing. What has that experience been like for you? Is there quality control issues? How has that experience been?
It's been a learning experience, that's for sure. It has. There's definitely been a lot of pain along the way and a lot of learning, especially in this exact 5 to 10 year time frame where we've had to deal with COVID related supply chain issues, and with that came a lot of our existing vendors no longer had the staff to be able to manufacture in the same way or at the same speed that they did before, so needing to rapidly find and vet and source new vendors for components, and deal with supply chain issues and all this sort of stuff. And now tariffs, of course, like doing the same thing where we need to find alternate pathways to doing stuff. Quality control has definitely been something that we didn't think about much at all at the beginning, when we were doing rounds of 10 to 50 units, because we weren't as price sensitive. We knew that our margins weren't fantastic at the beginning, and we could very easily visually inspect everything and make sure that it looked okay, and had a higher appetite for throwing something away if it was one or two. Now that we're doing 1,000 units or more, that starts to be problematic. And so, we're not ISO 9001, and we're a small team, so getting to ISO 9001 is probably still a little bit in the future. But through certain customers that required us to have certain processes in place, we've certainly come to adapt a lot of the sort of ISO 9001 like principles. And even though it's more work, see the value in, things like having SOPs for inspecting every single sheet metal component or every single sensor or every single, whatever it is, to make sure when it comes in that it's correct and within tolerance and all this sort of stuff, because there's not much worse than actually building something and finding that a hole isn't tapped or something like that, or even worse, getting 2 pallets of bent sheet metal that is bent in the exact opposite direction. And even just the needing to figure out how to recycle it all, and get the pallets out of our space because we are space limited. So yeah, it's been a lot of learning.
Yeah, I think again, a very good illustration of the detriments to not having good quality systems sometimes, and how at the end of the day, the ISO system is really a way to become smooth. Is how I would term it, and you're adding a little bit of formality and maybe some extra steps to your process, but in an effort to become smoother, less rough. You don't find a part is missing a tap far down the line. You find it as quickly as possible, and that smoothness eventually leads to some speed. So yeah, I think that's probably a very common tale for people listening.
Yeah, move slow to go far.
Yeah, absolutely. I'm wondering, obviously you've been very successful in this space and in being providing such innovation to people looking for these systems. What do you think the future of air quality monitoring is broadly?
Yeah, that's a good question. I think that historically speaking, most of the air monitoring that has been done is kind of top down. It's been done by, at the direction of the EPA per the Clean Air Act, which was written in, really the 70s, and hasn't been updated to a large degree since. And everything is based on sort of long-term data sets to make sure that large regions are in compliance. And a lot has changed since the 70s, both in terms of what we understand about the health impacts of air pollution, but also in how our lives can be adapted or changed based on real-time information. So there are, we are only on the monitoring side. We don't take action. We don't have air purifiers or anything like that would, take the action and clean it up. But you could easily imagine how having access to real-time information in a much broader sense could lead to real-time changes in how you operate a building or your HVAC systems or other things where you could, in an automated fashion, take action and make your life better off, as well as for us to just understand how things like, hyper-local air pollution impacts different people in different ways, and trying to come up with policy changes that may help ameliorate that to some degree. And so the Government Accountability Office, which I helped write a report with the GAO a year ago, last year, that took a look at the infrastructure that EPA oversees, or how we do air quality monitoring currently. And there are a number of recommendations on how to update and alter the architecture such that there is just much better, more real-time information that is much more up to speed with the 21st century.
Yeah, that I think that bringing it to the masses, sort of, and making it live. Obviously, any feedback loop is only as good as your data collection. So it absolutely makes sense. I'm curious. Yep. I before we jump into our rapid fire session, easy for me to say. I'm curious as to where you think QuantAQ fits in that. Do you think that doing more of the same, or do you think things differently? What is it?
Yeah, so I think there are. Yes, I think we play hopefully a big role in seeing that take place, and I think that, I mean, for somewhat selfish reasons, but also I think that there are a number of companies kind of building consumer grade sensors, and that's great. But like with a lot of other consumer tech, doesn't always provide the right answer. And it is often being done by people who don't really understand how it works. They're able to take a sensor and put it in a box and build a really nice app, and that provides a lot of value to people, but it is limiting in some ways. And so I think we take a different approach, and we do understand the science and how these things work, and try to communicate uncertainty, and help people understand what the data and information actually means. That being said, we only measure a few parameters right now, and there are a lot of other parameters that need to be measured, some of which we're working on and have previously had grants for, and do have active R&D efforts around creating new sensors to measure some of these pollutants. And then there are others that are incredibly hard to measure for under $500,000, and there's a lot of innovation that still needs to take place to be able to produce detectors and sensors that can measure these things in a way that allows them to be used in a similar fashion. And then on top of that, I think the data dissemination and communication and education piece is still very important as well, and is really just, people I don't think have generally cared about air that much or understand how important it is until the last several years, both with the kind of increase in wildfires, both in the United States and Canada, as well as COVID, and people understanding that, actually, indoor air it can be very important. It's how a lot of diseases are transmitted, and there are very real economic costs to not taking steps to clean up the air indoors and outdoors, that can just as an economy as a whole, we're just losing out on a whole ton of productivity and money by not taking action.
Yeah, I think it's definitely, speaking from a very simplistic perspective, I know that we have CO2 monitors in every building in our facilities, and when the level goes up, you definitely you can feel an impact. So I know that that's only one small micro example, and the better data, the more live data, as well as measuring different parameters. Obviously, I can only imagine the what you can do with that. So I'm very excited to see where you guys go. I do want to jump in before we conclude into our rapid fire segment.
Sure.
So, first question: are you an early bird or a night owl?
Early bird.
Early bird. What's one tool or piece of tech that you could not live without?
I don't know that there's one that I couldn't live without, but I do love a good oscilloscope.
Coffee or tea?
Coffee.
If you weren't working in air quality monitoring, what sector would you be in?
I probably would have stuck with baseball and or something around baseball.
Interesting. What's a misconception people have about air pollution?
I think that PM 2.5 is all that matters. It's the shortest way to put it.
Okay. What's the best piece of advice you've received as a founder?
To just do it.
Simple.
Start to fail. Yep. Just do it.
I like it. Last question. If you could get a live air quality reading from anywhere in the world, where would it be?
I don't know that there's anywhere. We've got stuff on all continents, so I think we've got it pretty much covered. So yeah.
So I already got it.
That's a great question. Yeah, everywhere.
Awesome. Well, David, thank you so much for coming on today. It's been very enlightening for myself, and I'm sure the audience, learning more about yourself, your company, and the impact you guys look to have on the world of air quality. So thank you.
Thanks for having me.
Until next time, bye-bye.